Hi everyone, is everyone seeing my screen? Okay.
Yes.
Okay, so good evening everyone. So I hope we are able to go through the chapters we are going to be treating today, which is chapter 6, hopefully 7 and 8 too also. So previously we already talked about data tidying. We have talked about the workflow, that's in terms of code style. And data transformation, we also talk about the basics and also visualization. So we're going to be starting chapter 6 today, which is actually workflow scripts and projects. So this chapter is actually talking about the tools that one can use to organize his or her scripts or projects. So a script is a single file that contains the code that is used to execute a particular task, while a project is a collection of these scripts. And a project actually includes scripts and data sets too, all together. So that is a project. And also have a script which can just be a single file. So this section, I'm just talking about the scripts. So just you can see an image we already have in this place. We can use keyboard control, that is Control-Shift-N, to create a new script. So you can see it's saying that to give yourself more room to work using the script editor, open it up by clicking the file menu. So this is the file menu. So I'm actually splitting my screen so that we'll be able to see both the R and the book itself. Is it comfortable with everyone? I don't know.
It's okay.
Okay. So I'm going to be using the keyboard shortcut, Control-Shift-N. So we say Control-Shift-N. It's going to create a new script. As you can see, it's a new empty script. So Control-Shift-N is just the keyboard shortcut for creating a new plain empty script, which you can now use to type in your code. So if you want to edit it, if you have a code file already, if you want to edit it, you don't need to retype everything, you just edit it. And once you edit it, you are able to now able to run the code again. So you just edit it. So that's why it's called the script editor. You don't need to be typing everything just to edit a particular code. So just here is now it's just a screenshot. So you can see our scripts in this place. You can now see the console showing the commands that were being executed. This is the plot, and this is our other tab that is showing our environment. That is our variables inside our environment. So I can also run code inside the script editor by using Control-Enter. So let's say I copy in this particular code, and I hope everyone already have the dplyr installed. So if I want to run it, I have various ways of running this particular script. I can just highlight everything and just say Control-Enter. So the output is going to show here. Okay. Okay, I need to install, I think I don't have this package installed, NYC Flights 13. So I think I need to install it for this to work. Okay, I think that's all. So now I can highlight everything and just Control-Enter. Now what's happening? Let me see. Okay, let me copy it again and paste. There was unexpected input not cancelled. I think trying to see where the issue is. Okay, what is all the problem is? Okay, let me see again. Unexpected inputs in not cancelled flights filter not inserted but delete. So what's the problem?
Does is NA understand quasi quotation?
You see it?
Does is NA understand those objects?
Yeah. It's actually code I copied here, so I'm surprised why it's not executing. I don't know what's the problem. Are you guys with your console there? Are you guys with your is your R opened there with the book?
Unfortunately, I'm not using R right now. Just
Okay.
watching.
I'm trying to see what the problem is, so I don't know. Okay. Okay, so I don't know what's happening, why it's not running. Let me try again. Still the same thing.
So debug it now.
Hello, that symbol there. Look at that symbol there. Remove that symbol.
Where's the symbol?
After that
Okay,
is
this
not.
particular, so that's where the problem is.
Remove that thing. That is the cause of the problem.
Problem. Yeah,
It's
yeah, thank
it's
you.
wrong.
Thank you. Okay. So I think this is it. So we have year, month, day, and mean. So I've already grouped by year. We have the month, day, and the mean. So this example is just trying to show us how we can execute code using the control enter on the R script. So how we can use control enter on the R script to execute our script. So we can also click on this particular source. This one will run the whole script, this particular source. It also does the same thing. Why this run is for a particular line. Maybe you want to just select this particular line. You can just click on run. So most of the times, if you click run, it can click the last line of code. So if you click run, it's going to execute this particular last line. That's by default. So if you actually want your script to be executed, you have to highlight everything. And you use control enter, you can just click on run or you click on source. So this is what this particular section is just trying to discuss about. And also the importance of, like earlier on now, you could see that I couldn't run the code because this package was not installed. I don't have this package installed. So it's very important most of the times. If you don't have a package installed, you install the package using the install.packages command. So there's actually a command I've forgotten that you can actually use to install, to actually load a package and install it if the package is not on your PC. So you don't need to be calling install.packages and also the library command. So with just that particular function, it checks if the package is in your PC. If it's not there, it's going to install it for you. If it's there, it loads it for you. You don't need to call this library dplyr or use the library function. So you don't need to use that particular function. So it actually does two work for you. It installs if your package is not available and loads it for you.
Is
that
function available on R in base R?
You said?
The function you just talked about, is it available in base R?
No. I don't think it's a base. I think it's an external package. Though I'm not sure though. I doubt if it's base. I think it should be an external package itself. So okay. It should be an external package. I'll try and see. I've forgotten the name of the function. I don't know. So we have RStudio Diagnostics. So in the script editor, there are a lot of signs you can see that let us know that we have a problem in our code. So for example, now I can just say X, Y, and let's see 10. Okay. So if I try to run this now, okay, I don't know. I'm trying to see this sign. Yeah. Okay.
Hello, instructor.
Yes.
That symbol you are seeing in the textbook is not assignment symbol. It's arrow backward.
Yes, that's what also I'm noticing. But I'm just trying to
That,
see how I can get it on my keyboard. I don't know. I don't know how I can get it on my keyboard. So that's what I'm trying to see. I see that's not the assignment symbol, it's also the arrow. I don't know. Okay, let's just try this example then.
No,
But I can't
there's a
get
package.
this
There's a package that that kind of applies some kind of glyphs to the operator and makes it look like an actual arrow.
You said?
There's a package that has some glyphs, form glyphs that are kind of modifies the operator to make it look like an actual arrow.
Okay, 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 okay. Thank you. Okay, so maybe we should just try this example. 3 NA. So one thing now is that this equals to, I don't know if it's double equals to or it's single equals to.
double is double.
It's double, right? Okay.
Yeah.
Let's see. So where 3 equals to NA. So let's run this and see. I don't know. Well, this is actually going, so I don't know why it was different from their own. Oh. Okay. So I think let me just try a common example which should work. So let me just give an example which they don't give. I think something like a double comma. Okay, a double comma is actually working. Let me see. Okay, question mark. Okay. Normally, when you are working with script editor, you used to show some squiggly lines. So if
Exactly,
we
sir.
write something that will get
Sir.
that. Yeah.
Something I want to say is as if which version of the R Studio are you using?
I don't
Because
know.
your own is not, it's supposed to be displaying those red alert, red symbols.
Yes, that's what I'm saying. That it's not
But
displaying it, so I don't know.
maybe you are using old version. Like my own now, any small mistake, it will show me immediately. Showing those symbols.
Okay.
I
Maybe
think
it's the
also at times in the settings, the R Studio settings, the global
The settings, right?
yes.
Let's check the settings. Let me check the settings then. Let's check the settings because I'm surprised also. Normally it's to show it, but it's not actually the console. So I'm not seeing any. I don't know if anyone have an idea where the setting actually is.
Go to the diagnostic now. Go to diagnostics. No,
Okay,
the
diagnostics.
diagnostic.
Okay, Okay.
Look at one if variable. Look up. One if variable is defined but not used. Go up.
Okay.
Check those things. Check them.
Let me check this also. Let me just check it like this. Okay. So let me just see if system. I don't know, but it's not used.
Then one more comment on this.
Okay.
You wrote a correct code now.
Yes.
As in the book, usually I don't know at the beginning of the book, they will indicate what version of R Studio is being used, what version of R is being used. So everything has to match, for it to get the exact same results.
Okay, it's possible. It's possible that might be an issue. That might be the problem, right? But another thing also I'm trying to see is that on a normal day, I did some things in this function, which normally, I don't know. Okay, let me see something. Okay, let me do this. I don't know.
Hello, sorry. Let me comment. Sorry. Is it possible that you can check your session and see maybe we get some information about your R Studio itself? So maybe you can pause the recording. Pause the recording while we troubleshoot.
To get the Zoom controls.
Just pause it for now.
I'm trying to get the floating. I don't know if it's possible to pause it on your own end. I'm trying to get.
Oh, okay. I can't because you are the host now. I've made you the host.
I'm trying to see.
Oh, okay. Okay, let me reclaim the host.
Okay, I think it's better.
Okay. Okay, I'll pause
yes. Okay, so for the model diagnostics to actually show, you need to save the file. So if the file is not actually saved, it's not going to show. So this is just an example now. It's telling us that argument Y is missing with no default. So you can see that we are supposed to provide 2 arguments here. Instead, we are providing only 1. So that is why we're supposed to have, that is why it's showing a warning sign here. So the same thing too, so if we should type this 3 equals to NA. 3 equals to NA. We try and run it. It is a single sign. Okay, now it's a single equals to sign. So it's also showing an equals to sign. It's also showing a warning.
It should be an error.
So we need to save it.
It should be an error.
Oh, I don't know. Is it double equals to?
No, it's single.
A single and again. Okay. So let me just clear it and see. Okay. Another issue again. Let me clear. I don't know what's happening again. Okay, I think the previous example worked. It's working, but this is not actually working. So this one is actually working, showing the warning, but this particular one is not working. So let's just save time since we already understand the gist of this particular section. It's just trying to show us about how the model diagnostics works. And also, if you want to set it, in case it's not set, you can go to our global options under code and you can find it under diagnostics. So ensure that everything is checked. So once everything is checked, we are able to make use of this particular feature on the IDE. Okay, so okay, next is also talking about saving and naming file. So we can save our file by actually using Ctrl+S. So if the case is not saved, we can actually save the file. So I think there's also a feature here on file, rename file, I think. So yeah, this is it. So you can actually click on this rename to rename the file name. So I can just call this example. So the name is going to change to example.r. So if I just go to file and click on rename, I'm able to rename the file. So this is one of the ways also of renaming the file. And also you can also rename the file from here. Your file is here. Let's say you have a file. Okay, I'm not using a project. So I don't actually know where this file is, but we can just click on a file from here. You can just click on this. You check on it. Okay. You check on the file and you click on this drop down. I think, okay, the option for rename is not here. Okay, this is the option for the rename. So this particular checked, we already checked on this particular file. So just click on this option. It's also another way of renaming the file. So this is also very important. If you want to rename a file without opening it when you're working on other projects. So I think that's what that particular part is trying to talk about renaming file. Also, file names should be machine readable, avoid spaces and symbols. Though when saving a file on normal Windows, on your Windows or File Explorer, you can actually save files or folders with space. But most of the time, it's a good practice when working with files that are going to be executed. That's when working with programming languages, like something like R or maybe Python. It's a good practice to always save file names or folder names without space. So one can actually use an underscore to save it. So an example like this, model first try. So you can, instead of keeping a space, you can use an underscore for it. So this is a good practice. it makes it machine readable. Even though it's human readable, it's not actually machine readable. So, but still with the underscore, it's both human readable and machine readable. And file names also should be human readable. So the file name should actually describe what is actually in the file. And file names should play well with default ordering. So start file names with numbers so that alphabetical sorting puts them in order they get used. So in case you have different files and you can use numbers to actually save them. One can be, okay, O1, data analysis, O2, data cleaning, maybe there are different scripts with different function, O3, model building, so things like that. You can actually save the files in that particular format. Okay. Okay, so now they're not trying to compare, I think, now look at this particular file here. So they're also comparing it with this one. So this is a very well-organized file structure under a project folder. We have O1 load data, O2 exploratory analysis, O3 model approach, O4 model approach 2. So O3 model approach 1, O4 model approach 2. The importance of this kind of thing is because when automatically the system usually sorts the files. So when it detects numbers, it sorts it based on the number from the lowest to the highest. So even though two files have similar names, by the time it detects numbers, one number is higher than another one. So it places the number that is lesser before the one that is actually higher. So this is one of the wisdom behind using numbers when trying to save your files. So we have projects. So you actually create a project when we want to work with various files or various data sets. So that is where you have a project. So, and one of the things that this project used to have a symbol, like it's like a diamond. When you go to your file explorer, you will see something like a diamond sign. So that diamond sign actually means it's an R project. So I don't know. If I have an R project here, I can just show it. Okay, no, not this. So this is the sign here, this particular icon here. So this is the R project. So most of this once you see this particular icon in the file, it means that particular folder is not just a normal folder. It's an R project. So which means even by opening this directly, it's going to open the whole project for you. So the importance of this is that you have linked all the files, the data sets, everything, you have linked them together. You can actually exchange information from various files. So inside that particular project, even if it's a function in another file, it's easy to call that particular function and use it in another script because they are both inside an R project. So that's one of the benefits of using, of making it inside a project instead of just creating a folder that is not an R project, because you can create a folder that's not an R project. So just create a folder and put all your files inside. But this is the benefit of using an R project. Automatically, when you create an R project, so let's create a simple R project now. File, new projects. So new directory. So let's just say new project. And I'm just putting it inside my documents folder. And so we have this option here, just like Python virtual environment. You can also use an R environment with this project. So most of your packages you install will be unique to that particular project. So in case packages update in the future, anything you are doing inside that particular project is not going to break. And if you actually have a Git repository, you can also connect to that particular Git repository by checking on that particular box. So for now, let's just give it A and create the project. Oh. Okay, now so this is an R project now. So now look at the difference. Can you see that immediately you create an R project is going to make sure that anything showing under your files is based to that particular R project. You can now see that particular icon I was talking about, that this is an R project. So you can create files from this place directly. So you can create your Python script here. Any other files you want to create, you can create it in this particular window. So I think I already talked about this. I think that's what I talked about. So, okay, this is very important too also. It's very important. And they usually advise in the book. I'm not very sure, right from the previous edition, they usually advise that this is always left unchecked. And normally when you install RStudio, I think this used to come checked. So this workspace. So what this does is that when you leave this checked, when you close your R, okay, let me demonstrate a practical example. Let me just go to tools, go to global option. I think it's under general. Let me put restore.r data into workspace as startup. So I'm going to put always, and I'm going to put okay. So I'm going to create like two variables. And C is equals to 7. So this is 3 variables I've created, A, B, and C. So I'm going to do something now. I'm going to close my RStudio. Okay, let me save my file. Save it. Let me just save the file. I'm saving it as S, and I've saved it. So I'm creating the RStudio. I'm going to go back to RStudio. Okay, I think let me open the project and see. Open project. So I think you guys can see the variables, right? You can see them that I created earlier on. So what this does is that anytime you leave this checked, once you close your project, you close your R, you come back to that same project again. The same variables you kept in memory are still going to be there. But most of the time, it's usually advised not to leave it checked. So you should always leave it unchecked. So which means if we go to our global options now, we have to leave this unchecked. So restore R data into workspace at startup and save workspace to R.data on exit. So it's supposed to always be on never. So, and I think they gave the reason here. Okay, this is it. They said, okay, to help keep your R script as the source of truth for your analysis, we highly recommend and instruct RStudio not to preserve your workspace between sessions. You can do this either by use blank states, or by mimicking the options shows in figure 6.2. So this will cause you some short stamping, because now when you restart RStudio, it will no longer remember the code that you ran last time. Nor will the objects you created or the data sets you read be available to use. But this short-term pain saves you long-term agony because it forces you to capture all important procedures in your code. There is nothing worse than discovering 3 months after the fact that you have only stored the results of an important calculation environment and not the calculation itself in your code. So the thing is that most of the times it's like trying to make sure to enable the good practice of actually focusing on the code than actually the outputs. So it's just like saying somebody runs an analysis now, and maybe he stores maybe a filtered data set already. Okay, Mr. Victor, all yes.
I think that there are some exceptions to every rule. I think in this case too, there are some exceptions.
Okay.
I think they also recommend that there are some processes for objects that require that maybe that are resource intensive, like some models that take a long time to build.
Yes.
So when you have such objects, you can just still save them for later use.
Yeah, it's true. Save them for later use. Yeah, it's true. Yeah, that's a good point. Yeah, it's true. It's true. So yeah, some models take time to load. It's true. So instead of spending another 2 hours again to actually run it, but I think can't one solve that problem by actually using loading the model into a pickle file. So one can actually serialize the model into a pickle file so that if someone wants to use it again, instead of leaving the model in the environment itself, because the model being in the environment prevents the use of
actually the one of the options you have is to save the object that is the model as an RDS object.
Okay, that's another thing also. You can save it as an RDS too also. Yes. So no, I've ever had the experience of saving a model, but I know in Python we save it as a pickle file or a joblib file, a JBLB or a PCKL file. So in case one wants to, that file is very small, no matter how big the model is. So once wants to use it, he loads it just like loading a data set, and you are able to use the model details again. So in short, this section is just trying to encourage the good practices of cleaning the environment itself, because it's more or less no matter the memory you are using, you are also using R memory and you're also using your system memory. So most of the times, most of these kind of things, you wonder why your system memory is filled up, when most of the times, most of these kind of variables are inside your cache, so you can't see them because you're having some of these heavy variables inside the storage. So the best is just to clear your memory. When you come back to your project, you rerun the script again. Once you have the script, you have everything. So IS is just that maybe the script might take time to load, but you already have the script already with you. But it's going to be very bad if you don't have the script, you only have the particular objects, and you have the objects and you don't know how you actually got it. So I think the best is always to have the scripts and clear the space. We always leave this particular workspace cleared up, and also to avoid conflict with other analysis, because if we have it on our environment too, also we want to conduct another work in another script, variable names that are actually the same can be conflicting with each other. So actually Control Shift so this is some commands here. Control Shift S to rerun a current script, and we have Control Shift O or F10 to restart R. So restarting R means the session is cleared. So once the session is cleared, any variable that was created, that was stored in memory, everything is going to be cleared. So it's like your R will not actually restart physically, or it will not actually like physically close and come up. So it's just the session that is clearing. So it's just like you are restarting the engine of a car. So everything is going to be cleared and all the variables is going to go. So this is just a simple example. I think we can restart R here. So I think you see everything is gone. So all the variables are already gone. So most of the times, maybe when the R hangs, or maybe you're having some errors, you need to clear and start afresh. Usually comes in handy. And this is also the command Control Shift 0 or F10 to restart the R. So they also give the key, the point and click option, which we just talked about recently now. Okay, now where does your analysis live? So R has a powerful notion of the working directory. So the working directory is actually where we're actually working. That is the current directory we are working on. Just like we created this project now, we created the A. A is actually the name of the directory, but the A is not just a normal directory. It's also an R project. So the R project is actually stored inside that directory. So you can actually get your working directory using the getwd command. So this is it. The users, this is where it is stored. So it's actually under documents and under A folder. So now where we are currently working now is under the A folder. So if you want to get your working directory, you can use this command, get the working directory, getwd function. And also, you want to set your working directory, you can actually set it. If you have a particular file path now, so I have a file path. Okay, let me see, I have something like this. Let me see. So I can say set working directory. Okay. I hope this works, because I don't know. So instead of it to be under the A folder, it's going to be under documents now. I don't know if this function works. Okay, so it's not supposed to be. Let me check the timing now because the working directory. Okay. Okay, so currently now our working directory now is no more on this particular E folder. It's actually on the documents folder. Okay, so it's not actually recommended. They say that there's a better way that one can actually use to set working directory. So it's actually just giving there's no example on it. Though it's not actually recommended. So it's just like being in a project and you're setting the working directory into another folder, another project. So I think I should explain this earlier on how to set up a new working directory. So I can just come over it again. New projects. So for those that use GitHub, they can actually we have three options. If you actually want to use it in a new existing working directory, you can go for this option. So we have another project inside another working directory. Or if you want to use it in a new directory, you go for this option, your other project in a new directory. Or you want to actually put your other project in a remote directory. That is something from a directory from GitHub. So you can use this version control. You have two options. You have Subversion. So Subversion is another type of version control system. So we have Git. So Git is actually the popular one. So we are going to use Git. When you put your repository URL there from the GitHub, we have our project directory name also. So what this does is that it's actually going to import, no matter how large the GitHub file is, you're going to import everything to your local directory. So you are bringing a particular GitHub directory onto your local machine. So I'm going to bring it there, and it's going to now create the R project inside that particular GitHub repository. So this is it for using the version control method. Okay, so yeah, they're just demonstrating an example of the working directory. So now this is just a code that we have. So the major thing about this code is that in this code, the last line actually writes our data to we're actually saving a plot. Or is it a plot or a data? I don't know. Let me run it and see. Okay, I think it's a plot. We are saving a plot and we're also saving. Okay, we're saving a plot and we're saving a data. So this actually go to plots, give us a plot. Oh, I don't know. I think my packages I have outdated packages here. I don't know. Okay, so this is a plot now. So we want to save the plot and we want to save this data also. That is this diamonds data from the tidyverse package. So if I also run this, let's run everything here. Oh, what's the problem? Okay, that's the problem. So let me just open this project again. So earlier on, we changed the working directory. I think that's why we are getting issues. Okay, I think so now we should be able to run it now. So now look at the image, look at the data. Oh, the data wasn't saved. Okay, we don't have a folder called diamonds.csv. That's why. So instead of let me just save it directly. So this is the CSV file now. This is our CSV file. This is the image. So we don't have a folder called data. As we have the folder they call data, it actually have worked. So let's say I create a folder now called data. And I just put the data back and I run it. So you can see now if I open this data folder, I'm going to see it inside. So I think this is it about the saving of files inside a particular working directory or project folder. So we have what we call the relative and absolute paths. Okay, Mr. Victor.
I noticed that your home directory, there's a space. Your home directory, see users.
Yes, is the there's a space there.
So you might want to do something about that sometime later because.
Okay, I'm not hearing clearly.
I said you might want to do something about that down the line, or because that.
Yes. The thing is that I've actually looked for is because of the way I saved my username for the PC. That was the mistake I made. Funny enough, I've tried to see how I will change it. I don't know if it will actually help me with that. How I actually change it. To change it to just a machine readable folder directory. But if you're facing difficulty with this, but if you can actually help me with that, I'll actually be grateful because I've actually searched. I wasn't able to change it. So, and sometimes that caused me a lot of problems. So
definitely.
And because Windows actually tolerates saving files with space, that's why the issue is. That's why it's tolerating it. If you are working on maybe Linux now, you can't save a folder with space in between. Thank you very much for it.
Now that Windows has comes with Linux.
Is it?
Now that Windows comes with Linux.
Yeah, Windows soft Linux.
Yes, so that would be challenging for you to use later.
I'll still work on it and see how I can try to save, because I don't actually usually like seeing it like that because it actually cause some serious issues if one is not careful. Thank you very much. Okay, so here we're talking about relative and absolute paths. Relative and absolute paths. So there are two different ways of accessing a particular file. So here now, let's just go through this. Once you are inside a project, you should only ever use relative paths. So this is the warning they're giving us. We should always use relative paths inside a project, not absolute paths. What's the difference? A relative path is relative to the working directory. That is the project's home. When Adley wrote data diamonds or CSV above, it was a shortcut for this. So this is actually the main part, but this was not actually a shortcut. So because we assume that the system knows the directory we are inside. So that is why if you want to save it in a folder, you need to specify the folder name. So then you leave the rest to the system. The system already knows that, okay, you're actually working on this project. So just specify the folder name and I'll save it inside. If you have another folder inside data now, let's say I have data and I have a filtered. I have a folder called filtered. So you're actually going to go to the data folder, search for the filtered folder and save the diamonds of CSV inside the filtered folder. So this is one of the advantages of using relative paths. So imagine having to type all this. And the kind of challenges that one can actually face also while even trying to do this. So this is one of the importance why relative path is important instead of using the absolute path. So they also mentioned something about the absolute paths point to the same place regardless of your working directory. So they look a little different on your operating system. So the absolute path actually have various different because in Windows, they use a double backslash. While on Linux, they use normal slash. So most of the times, if you are working with Windows, okay, I think let me just show an example of this. So you can see this is a forward slash. This is a forward slash. So this is how Windows mostly access paths. Unlike when we were on R, I was actually using I think it's a forward, okay, this is the backslash, right? I think that other one we are using is a forward slash. This one that we're using. So because of this difference, that's why I usually advise to use relative paths. So imagine having a script now with a absolute path and also a Windows backslash, and someone is now running it on a Linux system or a Mac system. So the person is going to be facing a lot of challenges. And it's even one of the disadvantages because it's not necessarily these details. It's the same as the details of the person that's going to be using your script. All this is not going to be the same thing. That's why it's always good practice to use relative paths. So they also mentioned that there's another important difference between operating system. I separate the components of the parts. Mac and Linux use slashes, and Windows uses backslashes. So this is the backslash. This is the slash, the forward slash that Mac and Linux actually uses. So there's another thing also. They say, unfortunately, backslash means something special to R. So I think backslash used for escaping, right?
Yep.
So that's why you need to give another backslash, because that backslash it means to escape a particular character. So by giving it another backslash, you are making it a regular backslash instead of a special backslash. So that's why most of the times you use double backslash when you're trying to work on with absolute paths for Windows. So a lot of these disadvantages is just best one even use the relative paths to avoid all these traits and things like this. So I think this is the end of the chapter. So we have some exercises. They say you should go to the RStudio Tips Twitter account to find one tip that looks interesting and practice using it. And also what other common mistakes with RStudio diagnosis reports. So we should also go to this particular link also to find out. This is also a summary of what I talked about inside this particular chapter. I actually want to go take one more chapter, but since my PC, this data imports, I actually had plans to take data imports, but my system is at 15%, and I don't think it will be sufficient for us. So I think we will have to stop this session today. God's willing, maybe the next session, still alive, we take 7 and 8. I think that will make us to be done with the whole introductory parts. And we will start the visualization, the transform, and so on. Because these are just giving us a preamble of all what we are going to discuss later. Because we also have sections on importing itself. We look at some of the sections too that are like covering most of the basic introduction we are doing. So just the preamble of all what we're going to be treating. So I think we'll just wrap it up today on this chapter 6. The next session, God's willing, will take over from chapter 7, and if possible, also take over start chapter 8. Okay. So in summary, we talked about creating an R script, creating an R project. We also talk about diagnostics. So diagnostics is very important because most of the times, even not for diagnostics, your code will be returning an error. You wouldn't know where the error is coming from. So especially when you are dealing with plenty lines of code, maybe you're building a Shiny app and problem is coming up from one place and you don't actually know where the problem is coming up. Or maybe the code is even running, but the result you are getting is not what you want. And actually due to some problems there. So one is able to see most of those diagnostic reports on the scripts, then one can detect that okay, there's a problem in this particular script or things like that. So this is one of the importance. So that's why RD is also RStudio is also a very good ID. If you're using VS Code, for example, now most of this you need to be installing it manually using extensions. You'll be installing various extensions. For that of Python, you have to be installing most of this. I think is this ZPEP8 or Black. So for that language, also you have to be installing extension that allow you to detect where there is problem or maybe variables that is not used or function that is missing an argument and things like that. Most of these things already come with RStudio ID, so you don't need to install anything there again. And I was even surprised that I was seeing this particular option today, this Copilot. I don't know. I've not actually focused on this section. I don't know that it was actually, they've actually updated, enabled it. I don't know, has anybody tried it?
I haven't.
Okay. but I think one might need an access key for it, or one doesn't need.
If it's in the idea, I don't think we should. We need anything like that at all. I think one.
Okay, I know that is paid. So the fact that it's paid, one we need some form of access to it. So I think we wrap it up. There's also this particular function here too, so yeah, is to be ignored. So there is a particular, I think is this what is to make it come up. I don't know. Is it this? Yeah, this is it. So if you actually want to section the code, you can actually use this. We are going to see it here. If I actually want to section the code, I can just call this data analysis. On a normal, it's not going to show, but you need to add these lines. So we are going to be seeing an outline. So this is another important way of sectioning your code when you're having plenty files. If you want to access it, just access it like this. So okay, that's it for today. Is there any questions before I shut it down? Before my system shuts me down?
Yes, sorry for the. Thank you for the lecture.
Okay.
The material that I use, can I get the link to that material?
Okay, let me just share it on the link, yes, sir, or the chat.
Is it on the link or on the WhatsApp group?
Okay, I think you can get on. I will send you on the WhatsApp group now. Yeah.
Hey, send it on the WhatsApp group, please.
I'll send it now. Okay.
Send these books. I really like them. Thank you very much. God bless you.
Sir. Thank you very much. So I think this is it for the class. So let me just end.
When next are we holding? Next Thursday?
Next month, I think, is a monthly session.
No, we normally hold every Thursday, I think.
Every Thursday? I think it's once in a month.
Is that Jara?
Yeah.
We held one last
time. It's in a month, every month. If we get more people, if we get more people to volunteer, we can have it weekly, but it's just 2 people that are volunteering now. So we can't afford to do it every week. We are also working. So that's why. So if you get more people to volunteer, it's about reading the book and just sharing the knowledge you've gained from it. So that way we can, like the way we're collaborating now, that's just the main goal of this program. So we read the books, we come together, we talk about what we've learned, and then we share with ourselves. So I hope maybe this would allow someone like you and Dr. Victor to join us. Oladapo is just about reading. You don't have to know everything, but we can all help ourselves during the session. So that's basically it. So we have another session tomorrow. That's for the epidemiology aspect. So Ridwan is going to take that as well. So that will be till next month. So we look forward to seeing you all tomorrow.
Okay. Thank you very much, everyone, for your presence. Thank you, Dr. Victor, for your presence. I really appreciate all your help also. Thank you very much. And every other participant also. Thank you very much for your attendance.
So thank you, everybody. Bye-bye.
Okay. Bye-bye. Have a nice day.
Thank you. Bye.